Okay, pre-calculus, let's go over a couple of ideas. We're going to take a look at some intercepts with some juicier problems. We're going to learn average rate of change and then equations of secant lines. This all sounds pretty good. We are getting near the end of the chapter, so stuff's going to start to tie together a little bit. Okay? Remember, when we're finding intercepts, intercepts are points. Points where the graph crosses the x and the y-axis. So I'm going to find the x-intercepts and the y-intercepts, and I'm going to label my work nicely. To find an x-intercept, you let the y number equal 0. So I'm going to put 0 in for y. X squared minus 4 over x squared plus 1. Does anybody know how to solve something when there's a fraction on one side? That's right, we're going to cross multiply. So let's take the 0 and put it over 1. Now he's a fraction, okay? When you cross multiply, I want you to draw an equal sign on your paper first. This is the only time when you have a proportion that you're allowed to do this. Okay, so you cross one way. I'm going to cross this way. 0 times stuff, and that makes a 0, so you put your answer on one side. Okay, then you cross the other way, and you put that answer on the other side. X squared minus 4. After you cross multiply, there should be no more fractions. You cross one way for the left side, one way for the right side, and it doesn't matter where you put it. Okay? How am I going to solve something like this? A power of 2 means 2 answers, so I'm going to go ahead and solve by factoring x plus 2, x minus 2, and it's very clear how we're going to get 2 solutions here. Okay? Some people like to move the 4 to the other side, okay? And then they like to square root, which is a great technique. Just don't forget, you people, that you're also going to get plus and minus 2. Okay, 2 solutions. All right, are those good answers for x-intercepts? No, because intercepts are points, remember? So we have to say plus and minus 2, comma 0. All right, what about the y-intercept? Let's go find that by letting x equal 0. We let x equal 0, so y is going to equal 0 minus 4 is negative 4. 0 plus 1 is 1. Okay, and so our final answer here for y-intercept is 0, comma, negative 4. And that's how you find intercepts when you have a fraction. Okay, let's do another one here. Find the intercepts for this quartic. It's a quartic problem, okay? So I'm going to organize my work. X-intercepts, y-intercept. Okay. To find an x-intercept, I let the y number be 0. Okay, so in a problem like this, I'm letting the y number equal to 0. And this is an equation with an equal sign. If you have an equation, you can solve it. Okay, if it doesn't have an equal sign, please don't just add that in. That would just be an expression I'm asking you to factor. Okay, and how does this factor? Well, let's see. X to the 4th would come from x squared times x squared. And then I need to make a minus 4 here, so I think it's going to be minus 4 and plus a 1. Let's double check that this actually works, okay? X squared, let's do the outers and the inners. A positive 1x squared minus 4x squared. Does that make minus 3x squared? Certainly does. Okay, but I notice right here that this is also a difference of squares. So I'm going to go ahead and factor again. X plus 2, x minus 2, and then we have x squared plus 1. Okay, so I can see what the solutions or the x-intercepts from here are. We have negative 2 comma 0, positive 2 comma 0, but this does not factor. So I'm trying to figure out how I can solve that, and maybe I'll do it algebraically. What if I say x squared plus 1 does equal to 0, and I try solving it by maybe doing square roots. So I will move the 1 to the other side, okay, and then we're going to square root. And what happens when you square root a negative? Yeah, it cannot be done. okay? This does not work. So I couldn't get the answers from factoring. I can't get them from square rooting. So there are no more x-intercepts, which means this quartic only touches the x-axis in these 2 points. All right, let's take a look at finding the y-intercept. Okay, so this is always going to be the easier one that you have to do. To find a y-intercept, you let all these x's equal to 0. Everything there zeroes out, and you just get -4. So the y-intercept is 0, comma, -4. Okay, so you might have to use some factoring and some solving skills to find intercepts. Okay, let's talk about average rate of change. Okay, so average rate of change is a fancy way of saying slope. How does the graph change? Okay, except slope can really only be done when it's a line, but we're going to use the same technique. Okay, so we're going to do delta y over delta x. You might have also heard this as rise over run. Okay, I think we just studied this last time, but we'll do y2 minus y1 over x2 minus x1. But remember I said it doesn't really matter the order as long as you keep the pattern. You could do y1 minus y2 as long as we do x1 minus x2. Okay, so that's how you find the slope. All right, what are the steps to finding the average rate of change? Here's the steps, okay? Write this down. Number 1. First, you have to find 2 points. If you don't have 2 points, you have to find 2 of them. Then you calculate the average rate of change. And when I say average rate of change, that's a fancy way of saying the slope. Okay, so I noticed that this first function right here, f of x, is equal to 3x squared. Okay, and they want me to find the average change from 1 to 3. So the first thing we have to do, step 1, is find 2 points. I'm going to take the value of 1 and plug it into the function, f of 1. So let's plug a 1 in, that's 3 times 1 squared, and I get an output value of 3. So the point has an input of 1 and an output of 3. That's the point 1 comma 3. Now, let's plug in a 3. Please take the function and evaluate 3. So if the input is 3, that's going to be 3 times 3 squared. So that's 3 times 3 times 3, 27. So when the input is 3, the output value is 27. Okay, so step 1 was find 2 points. Check, we did that. Okay, now we have to officially find the average rate of change. When you start doing stuff on your paper, please label what you're doing. Okay, are you doing f of 3? Then write that down. Just don't start calculating things without telling people what you're doing. I'm going to do average rate of change, and so I'm going to write that. And y minus y over x minus x in reduced form gives us a value of 24 divided by 2 makes a 12. Makes a 12. Average rate of change. All right, let's try it again. What would be the average rate of change if I went from 1 to 5? Okay, so I've already plugged in 1 up there. I'm just going to steal that answer. F of 1 gives me a value of 3. Okay, I did that work already. But now I have to plug in a 5. So what is f of 5? Let's see, 3 times 5 squared. That makes 75. So I have the point 5, comma, 75. Okay, step 1 was find 2 points, and now it's time to find the average rate of change. I always like starting with the bigger number. 75 minus 3 over 5 minus 1. Okay, survey says, type it in, please. No, go get your calculator and type it in. All right, are you really doing it? Okay, let's see. Some of us got 18. And now it's your turn. Please find the average rate of change. Make sure you do a good job here of labeling all your work, okay? And then over here, please find the average rate of change. Okay, great. Let's go to the next page. So people that just came from geometry classes might recognize this word a little bit. Okay? A secant line. And what a secant line is, okay, well, it's a line, of course. It's a line that intersects. I think you did this a lot in geometry with like circles and stuff. It intersects twice. Twice. Does anybody remember what happens, what it's called if the line touches once, if it just brushes once? Okay, so let's take a look at a fun little graph, something that goes like this. Up, down. Let's make it fancier than cubic. Let's go like this. Okay, make it be a quartic. So here's a fun little graph, okay? And I'm going to draw a line intersecting 2 times. So you have to have a line. And it intersects in these 2 points. Okay, so we're going to label this point right here. I'm going to call it A, comma, what do you think goes there? Nope, we're not going to say Y. Nope, we're not going to say B. All right, let me help you. It's going to be f of A, the function at value A. All right, let's try again. If this is the point and I call it B, what's the Y value for B? That's right, f of B. Okay, so I have a secant line touching at 2 points. It's kind of like x and then f of x. A, f of A, B, f of B. So that's the Y value that goes with B. Okay, how do you find this equation of a secant line? This is kind of like algebra. It's lines all over again, okay? The first step is going to be find 2 points. Just like it was a second ago. Find 2 points. After you find 2 points, you're going to calculate the average rate of change. Calculate the average rate of change, okay? That's what we just did on the previous page. I'm going to call this, okay, the slope. Okay, after you find the average rate of change, we're going to write the equation, okay, of the secant line. Write the equation of a line. Okay, now we just studied a chapter or a section in our notes, and there's 2 ways that you can do this, okay? I like point slope, y minus y1 equals mx minus x1. It's a great way to find the equation of a line. Or you could always go with Old Faithful, y equals mx plus b. Okay, so those are the steps that we're going to follow to find the equation. Okay, so here's a function called g of x. Here's g of x, okay? G of x is a parabola, right? Find the average change from -2 to 1. Okay, so this is us finding the slope. So first we're going to have to do stuff like g of -2. So let's take our first value and plug it into the function. We've got 3 times -2 squared minus 2. The input value is -2 plus 3. And we're getting a value of, okay, we could always use our calculators. Let's just make sure people understand how we would do this. In the graphing calculator, you could use parentheses. We've got -2, quantity squared, minus 2, okay, but the input there would be -2. There's a big difference. And then plus 3, okay, so the value for the output would be 19. So when we plugged in -2, we got 19. All right, we have to do it again. Let's plug in a 1, g of 1. So we've got 3 times 1 squared minus 2 times 1 plus 3, and that makes, that's going to make a 4. Okay, so we have the point 1 comma 4. All right, so we found the 2 points on this parabola. One of the points is starting at -2, and then the other point starts at 1. There they are. Okay, but remember, we were supposed to be finding the average rate of change. So the average rate of change between these 2 points, 19 minus 4, -2 minus 1, gives us 15 over -3, -5. Okay, but that is not the equation of the secant line. That's just the slope. Okay, let's take a look at this. Question B. Okay, so they're guiding us through getting to the equation of the secant line. I need all this information. Find the equation of the secant line, okay, containing the point -2 comma g of -2. Wow, what is that? G of -2. Why is that so fancy? Okay, let me tell you what they're saying here. -2 is the input. The question is, what's the output? They're calling it g of -2, okay? But I calculated that and got a 19. They're not going to put 19 here and give away the answer, okay? But that's them saying the y value for -2. Same thing here. What's g of 1? The output value is actually a 4, okay? But they're not going to tell you the y values. You had to find them, and I did. So to find the equation of the secant line, I think I'm going to go with point slope. So I'm going to use y minus, give me a y. So we've got a couple of points here. I'm going to use the smaller numbers. 4 equals m, then x minus the x value is 1. Okay? Now all we have to do is distribute. So that's going to be -5x. This is plus 5. And then if I add the 4, it's going to make plus 9. Plus 9. Okay. Now, there is a way to check all of this, okay, with our graphing calculator. So what I want us to do is open up that app and play along here. Okay. We're going to graph g of x, which is a parabola, and this secant line right here. And we have to get a good viewing window. So let's go to our calculators. Now let's go to y equals. Clear out anything from your past. The g of x function is 3x squared minus 2x plus 3. And the secant equation that we calculated was -5x plus 19. Okay. So I want you to type those both in. Pause the video if you need time to do that. Okay, the second thing we're going to do is get a good viewing window. So I'm going to go to graph. Oh, what is this? Oh, this is an icky window from a previous problem. Okay, this is not going to work. So I'm going to go to zoom, and I'm going to get the regular graph paper, 10 by 10. Do you remember which one that is? Okay, that's going to be number 6, standard. Okay, this is a much better view. But am I seeing everything? I see the parabola, and I see the line, but I don't see where it's intersecting 2 times. A secant line is supposed to touch twice. Okay, when you want to see higher up the y-axis, you have to go to window, and you're going to change your y maximum. Okay, it's only going as high as 10. How high should we go? Some people say go 20, so let's give that a try. Parabola, and oh, that is still not high enough. That's still not high enough, so we're going to have to try a new window. Oh, hang on, people. I typed a 19. We need to type plus 9. Okay, maybe a little higher, but that did fix one of my problems. Let's go up to 30 and see if it looks better. Parabola and a line. Okay, I can see the two intersection points clearly. Okay, and I did have a typo in one of my equations, but this is a good window. Okay, so let's just draw a sketch of what we're seeing. Okay, so I have the parabola, which is called g of x, and then I see this secant line touching twice. Okay, it is a downhill line, just like I thought it would be. Okay, secant line touching two places. Okay. Now, what's happening? This question said find the average rate of change from -2 to 1. Okay, so this first point that I found over here was -2, 19. And then the second point was 1, 4. And I think this is the line that's going between them. Okay, but we're going to check with our calculator. So how can we find that intersection point right there? Okay, a couple different ways you can do it. Like we did last week, second, calculate intercept. First curve, enter, second curve, and then close by it. -2, 19. Perfect! That point is working. Okay. There's also something else you can do. It's very fast. Remember, you could hit the trace button, and you can type in any value you want. When you hit the trace button, I'm going to type in the number 1, and I really hope that the point 4 comes up. Yes, 1, 4. These are the points, and that is the line going through them. That is the secant line. Okay. So the steps to doing this is find the 2 points, find the slope, and then write the equation of a line. Make sure you put it in slope-intercept form. Okay. Now there's one for you to try right here. Here's f of x. I want you to find the equation of the secant line, okay, from 0 to 3. So you're going to have to do f of 0, f of 3. You're going to have to make 2 points. Okay. And then, what are you getting for the average rate of change? Okay. Now you have to find the equation of the secant line. Okay, and I want that to be in y = mx plus b form. Great job, pre-cal.